Okay, wow, you guys really went all out this time. Sent me a ton of stuff on accelerated computing and AI. I mean, I knew this stuff was getting big, but this is a lot to process.
No, it really is impacting almost every field these days.
Yeah, it seems like everywhere I turn, from drug discovery to climate modeling, even my personalized recommendations, sometimes it feels like they know me better than I know myself.
Yeah, that's the power of AI at work, analyzing massive amounts of data to make those predictions.
Right, pretty amazing. But I have to admit, I'm feeling a bit overwhelmed by all the technical jargon. Like, what exactly is accelerated computing, and how is it different from just, regular computing?
That's a great question. It's all about handling the massive increase in data and complex calculations that we see in areas like artificial intelligence and high performance computing, or HPC. Traditional CPUs, those just can't keep up anymore.
So it's like trying to run a marathon in flip-flops.
Yeah, kind of. You need specialized hardware to really get the most out of these advanced applications. And that's where accelerated computing comes in, specifically GPUs, or graphics processing units.
Okay, GPUs, I've heard that term before. But I thought those were mainly for gaming and graphics, not like serious scientific stuff.
They were originally designed for graphics, that's true, but they turned out to be incredibly good at the kind of parallel processing that AI and HPC need. They can handle massive amounts of data simultaneously, which is what makes them so powerful for these applications.
So it's like having a team of chefs instead of just one person trying to cook a feast.
Exactly, and the results are pretty amazing. One of the most striking examples is in molecular dynamics. Before, scientists were limited to simulating small molecules, like really small. But with GPUs and AI algorithms working together, they can now simulate entire proteins, viruses even.
Whoa, that's a huge jump.
Right. It's a game changer for fields like drug discovery, material science, you name it.
So we're talking about breakthroughs that just wouldn't be possible without this technology.
Precisely. And speaking of breakthroughs, one company that's really leading the charge is NVIDIA.
Yeah, their name was all over the stuff you sent me. What makes them stand out in this field?
Well, they've kind of gone all in on accelerated computing. It's not just about making GPUs for them. They've developed this whole ecosystem of hardware and software designed to work together seamlessly.
So it's not just about the individual parts, it's about how they all fit together.
Exactly. They've got GPUs, of course, but also DPUs, which handle data processing, and even CPUs, all optimized to work in harmony. It's like building a superhighway for data to flow through.
And that's what allows them to achieve those incredible performance gains I keep reading about.
Absolutely. In fact, they've been outpacing Moore's law by a significant margin. We're talking a 26-fold increase in performance in just the last 6 years.
26 times.
Yeah.
That's crazy. Moore's law is supposed to be this fundamental limit of how fast technology can improve.
Right. But they're finding ways to innovate and push those boundaries. And the best part is, it's not just about raw speed. This approach is also incredibly energy efficient, so it's better for the planet and it keeps costs down.
Okay, so it's faster, more powerful, and better for the environment. Sounds like a win-win-win. But can we dig into some specifics? You mentioned NVIDIA's DGX systems earlier.
Sure. Those are basically purpose-built systems for AI and HPC workloads. The top-of-the-line model is the DGX A100, which is packed with features that make it a true beast.
Okay, beast is a good word. What exactly are we talking about here?
Well, for starters, it has 8 A100 GPUs, which deliver a mind-boggling 640 gigabytes of total GPU memory. That's more memory than most laptops have for everything.
640 gigabytes. I think my brain just short-circuited trying to imagine that.
It's a lot, and it allows the DGX A100 to handle truly massive datasets and train incredibly complex AI models. On top of that, you've got NVSwitch technology, which allows the GPUs to talk to each other at lightning speed, up to 600 gigabits per second.
So no traffic jams on that data superhighway.
Exactly. And the storage is no slouch either. We're talking 25 gigabytes per second bandwidth, which ensures that data can flow in and out of the system without any bottlenecks. It's all about maintaining that smooth, efficient flow, even when you're dealing with truly massive workloads.
It all sounds incredibly impressive. But I'm always curious about the real-world impact. Can you give us some concrete examples of how this technology is actually being used?
Oh, absolutely. Let's start with big data analytics. Imagine you're a company or a research lab trying to extract insights from mountains of data. The DGX A100 can execute queries on those massive data sets twice as fast as previous systems. That means quicker discoveries, faster decision-making, and a whole new level of understanding.
So potentially life-saving discoveries happening twice as fast. That's huge.
It is, and it's not just about speed. It's about accuracy and efficiency as well. For example, in real-time AI inference, which is crucial for things like voice assistance or natural language processing, the DGX A100 achieves up to 1.25 times higher throughput. That means faster responses, smoother interactions, and a more seamless user experience.
So this is the tech behind those chatbots that can hold surprisingly human-like conversations.
Exactly. And when it comes to training those really complex AI models, the kind used in recommendation systems or medical diagnosis, the DGX A100 can handle those tasks up to 3 times faster than previous systems.
So that means we can develop and deploy more sophisticated AI applications much more quickly.
Exactly. And for organizations that need even more power, there's the DGX SuperPOD. Think of it as a cluster of DGX A100 systems all working together in perfect harmony.
So it's like a supercomputer made of supercomputers.
You got it. And it's not just about throwing more hardware at the problem. The SuperPOD's design was meticulously crafted to minimize bottlenecks and ensure maximum performance. It's like a finely tuned orchestra of computing power.
Okay, I am officially blown away. But what about the software side of things? You can't just have all this amazing hardware without the right tools to actually use it, right?
Of course not. That's where NVIDIA's software ecosystem comes into play. It's a suite of frameworks and tools designed to make it easier for developers to build and deploy AI applications using these systems. Think of it as a toolbox filled with everything you need to create the next generation of AI-powered solutions.
So what are some of the most important tools in this AI toolbox?
One of the most exciting is called Nemo. It allows developers to build and customize incredibly powerful generative AI models, including large language models with billions of parameters. Those are the kind of models that can hold human-like conversations, write different kinds of creative content, and answer your questions in an informative way.
So this is the key to unlocking those next-level AI capabilities, the ones that seem almost magical.
Exactly. And then there's Riva, which is a toolkit specifically for building real-time conversational AI applications. It's all about making those interactions as smooth and natural as possible.
So it takes the power of Nemo and makes it practical for building real-world applications. What about incorporating real-world physics into AI models? Is that even a thing?
It is, and NVIDIA has a framework for that too. It's called Modulus, and it's designed for developing physics-informed AI models. They can simulate real-world systems with incredible accuracy because they take into account the laws of physics.
Wait, so we're talking about AI that understands not just data, but the fundamental laws of the universe.
Pretty much. These physics-informed AI models, sometimes called digital twins, have huge potential in fields like engineering, climate modeling, and even astrophysics.
This is all just blowing my mind. What about the connection to quantum computing? That's a whole other level of mind-bending stuff.
It is, and it's still a very young field. But researchers are already using supercomputers like the DGX SuperPOD to simulate quantum computers and develop hybrid applications that combine classical and quantum computing.
So they're using today's most powerful technology to explore the potential of tomorrow's. That's pretty meta.
Right. And NVIDIA has an SDK called Quantum that specifically accelerates quantum computing workflows.
Okay, I'm getting the sense that NVIDIA is pretty much everywhere in this field. But let's bring it back down to earth for a minute. What are some concrete examples of how these DGX systems are being used to solve real-world problems?
Well, one really inspiring example is an organization called AI for Parat. They're using DGX infrastructure to build open source language AI for Indian languages.
That's incredible. So this technology is being used to break down language barriers and make information more accessible to people around the world.
Exactly. It's about using AI for social good. And beyond that specific case, DGX systems are being deployed across a huge range of industries. Everything from manufacturing and energy to healthcare and finance. They're used for industrial inspection, drug discovery, fraud detection, developing autonomous items. The list goes on and on.
Wow, it really is everywhere. It's clear that this technology is already making a tangible impact, and the potential is truly limitless.
It is, and that's what makes this field so exciting. It's not just about faster computers, it's about unlocking entirely new possibilities and using those possibilities to build a better future.
You know, going through all of this has really highlighted for me just how quickly this field is evolving. It's almost like Moore's Law has been put on fast forward.
It has, in a way. But it's more than just processing power. It's the convergence of AI, HPC, and quantum computing that's creating this perfect storm of innovation.
And it's not just about technology for technology's sake. It's about using these tools to address the world's most pressing challenges.
Absolutely. From developing new treatments for diseases to combating climate change to understanding the universe at a deeper level, this technology has the potential to make a real difference.
And that brings us back to you, our listener. We've explored the technical details, the performance gains, and the real-world impact. What does it all mean for you specifically?
That's the question I want you to think about. How do you see this technology impacting your own field of expertise, your own passions and interests?
It's easy to get caught up in the abstract, but this is technology that has the potential to transform real lives in very concrete ways.
And it's already happening. We just saw how AI for Hara is using this tech to build language AI for Indian languages, promoting inclusivity and breaking down communication barriers. That's just one example. The possibilities are truly limitless.
It's inspiring to think about how this technology can be used to address real-world challenges and create a more inclusive and equitable future. But for now, we'll have to pause our deep dive here.
Be sure to join us for part 2, where we'll continue our exploration of this fascinating world.
We'll delve deeper into the ethical considerations, the potential risks, and unintended consequences, and what it all means for the future of humanity. Until then, keep diving deep.
And it's a conversation we really need to be having, especially now, with how fast things are changing.
Yeah, I mean, this stuff is already impacting our lives in so many ways,
Yeah.
and it feels like it's only going to accelerate from here.
It is exponentially. And that's why it's so important to be thinking about the implications, the ethical considerations.
Right, like how do we make sure this technology benefits everyone, not just select few?
Exactly. And how do we mitigate the potential risks, the unintended consequences? It's not all sunshine and roses, right?
No, definitely not. There are some big questions we need to be asking.
Big questions, tough questions, like how do we foster a future where humans and machines can coexist and thrive together? It's a partnership, not a takeover.
Yeah, that's a good way to put it. It's about collaboration, augmentation, not replacement.
Exactly. And that's something I think NVIDIA really gets with their whole full stack approach. It's not just about building the fastest chips. It's about making sure those chips are accessible, that they're used to solve real problems.
It's almost like they're trying to democratize AI, make it available to everyone, not just the big tech companies.
Yeah, in a way. And I think that's really important because this technology has the potential to be incredibly transformative in so many different fields.
It's not just about crunching numbers anymore. It's about using AI to solve problems that were once considered impossible.
Right. It's a whole new way of thinking about computing. It's about augmenting human intelligence, not replacing it.
And ultimately, it's about using this technology to create a better future for everyone.
Absolutely. And on that note, I think it's time to wrap up this part of our deep dive.
Wow, time really does fly when you're exploring the frontiers of technology.
It does. But we've only just scratched the surface. There's so much more to explore, so much more to learn.
So be sure to join us for part 3, where we'll continue this journey.
We'll delve even deeper into the ethical considerations, the potential pitfalls, and what it all means for the future of humanity.
Until then, keep diving deep. It's amazing to think about how far we've come just in this conversation, from the nuts and bolts of GPUs to these big picture questions about the future of AI. It's been a real journey.
It has, and it just highlights the importance of having these conversations, of really grappling with the ethical implications of this technology.
Yeah, it's not just about the cool factor anymore, right?
Yeah.
We have to think about the potential downsides, the unintended consequences.
Exactly. Like we talked about earlier, we need to make sure this technology benefits everyone, not just a select few.
And that it's used responsibly, ethically. I mean, we've
Yeah.
seen how powerful it can be in fields like medicine, scientific research, even art. But there's also the potential for bias, and job displacement and all sorts of other issues we need to be mindful of.
Absolutely. It's easy to get swept up in the excitement of it all, but we can't forget about the human element.
Right. Ultimately, it's up to us to shape the future of AI, to make sure it aligns with our values.
And that's where informed, engaged citizens like you, our listeners, come in. You have a voice in this. By understanding this technology, you can contribute to the conversation, ask the tough questions, and advocate for responsible development and deployment.
It's a powerful reminder that we're not just along for the ride. We have agency. We can help shape the future of this technology.
Exactly. The future isn't predetermined. It's something we create together.
And I think our listeners are the kind of people who are up for that challenge. Curious, engaged, not afraid to ask the tough questions. Well, it looks like we've reached the end of our deep dive, unfortunately. It's been an incredible journey.
It has. A real pleasure exploring this world with you and with our listeners.
Absolutely. But before we sign off, I want to leave everyone with a final thought. The future of accelerated computing and AI, it's incredibly exciting. The possibilities are, well, pretty much limitless at this point. But it's not a predetermined path, right?
Right. It's a future that we, collectively, have the power to shape.
So keep exploring, keep learning, keep asking those tough questions. Because the future is in our hands, and it's up to all of us to build a world where this technology empowers humanity, creates a brighter future for everyone. Until next time, keep diving deep.